So one of the questions was confusion about chapter 23, number 25. And this was number 25. Equation 23.11 gives the electric field on the axis of a charged ring. Where is the strength of the electric field the maximum? So there's this equation that we have, EY equals 1 over 4 pi epsilon naught times Q times Y divided by R squared plus Y squared to the 3/2. Okay, how do I find a maximum of a function, a maximum of something? Do what? Derive and set it equal to 0? Yeah, so derive means differentiate. So take the derivative and set it equal to 0. If you go onto the course discussion board where the question was posted, there's a YouTube video linked that will show you exactly how to work this. It's taking a derivative, right? So take the derivative, set it equal to 0, and solve for y, and that will give you the answer. So your answer to this one is on YouTube. If you still have questions, let me know. Let's do 23, number 33. So number 33, we have a semi-infinite line carrying a uniform charge distribution of lambda coulombs per meter that lies along the positive x-axis from x equals 0 to x equals infinity. Find the components of the electric field at the point with coordinates x, y with z equal to 0. Assume x is greater than 0 and y is greater than 0. So what does that all even mean? Who knows? Draw a picture. Horizontal is the x-axis, vertical is the y-axis. Where is this line charge lying? Along what axis? A semi-infinite line carrying a uniform charge distribution of lambda coulombs per meter lies along the positive x-axis. Along the positive x-axis. From what to what? From x equals 0 to x equals infinity. So I have an infinite line charge. It's going to look something like this. I'm going to draw it as a cylinder just because. There's my line charge. And the charge is distributed according to the distribution lambda. Lambda, what is that short for? What does lambda mean? What is the lambda equation? Charge density? So this is, what is the charge density on a line? Oh, this will be a tough exam. This is Q over length. Charge per unit length is charge density for a line. So what would the length be here? What variable should I use for length?
Oh,
X? Why X? Because it's along the x-axis. If it was, so one thing I could change if I put this on the exam. I could say it's along the y-axis. So what would I change? And it'd be Q over Y. Everything else would be the same. Solve the exact same way. Okay. All right. Some other things to do. Bless you. We want to know what is the electric field at a point with coordinates x, y, where x and y are both greater than 0 and z equals 0. So what does that mean? Where is x and y both greater than 0? Do you remember coordinates for like when you draw the coordinate axis, coordinate grid, and you have region 1 or 2 or 3 or 4, one of those quadrants? Which quadrant am I in? If x and y are both greater than 0, then I'm in quadrant 1. So I'm somewhere right around here. So let me just pick that as my point. Okay. I want to find what the electric field is at this point. So I can denote where that point is. It's some distance y along the y-axis. It's some distance over along the x-axis. We'll call that x. And if I go from the origin, why not? I could go from anywhere, but I'm going from the origin. I can call that distance r. Okay. And what is r equal to in terms of x and y? Square root of x squared plus y squared. How do we get that? Pythagorean theorem. That bastard Pythagoras. We hate Pythagoras. He sucks. I have a right triangle drawn here. What do we usually put into right triangles? We know all the sides. What else do we usually want to know? We want to know an angle. I picked this angle. Could I pick the other angle? Yeah, sure. Pick either one, whichever one you want. I just picked that one. Okay. So let's say I want to know the cosine of this angle, cosine of theta. What's the cosine of this angle in that triangle? Y over r. Y over the square root of x squared plus y squared. I'm on the adjacent side of that triangle divided by the hypotenuse. And sine of theta. What's the sine of theta? X over r. X over square root of x squared plus y squared. All of this is just a setup so you can actually solve this. So to go from here to find the electric field, when I have charge that's distributed in a line, I can't just use the normal electric field equation. What's the normal one? What's the easy one? Electric field of a point or of a charge. KQ over R squared. That's the normal one. Why can't I use that one here? Do I have just one charge Q? No, my charge is spread all along a line. So when I'm spreading my charge along a line, I kind of need to use something that will take that into account. That's where calculus comes into play. This is why Newton developed calculus. And because he was stuck inside during the Black Plague. So we use this more general equation for electric field. All of this jazz. The differential of the electric field is 1 over 4 pi epsilon naught. How else could we write that? That's just K times dq over r squared. Yeah. I have some pieces that I can plug in here. I have dE. Instead of 1 over 4 pi epsilon naught, what can I do? Let's just make that K. dq. I wasn't given a Q. What was I given to tell me about the charge? I was given lambda. So I need to mess with this to get dq out of it. I need to figure out what dq is in terms of variables that I was given. So how do I find q from that? Multiply x to the other side. So this gives me q is equal to lambda times x. How do I get dq now? Take the derivative. So if I want dq, that's the first variable, lambda, times the derivative of the second, which is dx. Then what else do I have to do? That's a product. Plus the second, what's the second variable? X times the derivative of the first. What's the first variable? Lambda. So I have to do d lambda. That is 0. Do we remember why that was 0? Lambda's constant. By definition, it's the linear charge density. That's constant. If I didn't give you a line, if I gave you a sheet, what's the symbol for the sheet charge density? Greek letter sigma.
Oh.
Right there. And what's the volume charge density? That's rho. All of these, the second part of this, would go to 0. By definition, they are constants. Take the derivative of them, they go away. Okay, so I can take this dq and I can plug it in for my lambda, for my dq. So now instead of dq, I have lambda dx. And then I also have r squared. What's r squared? square root of x squared plus y squared. That's r, and then I square that. So now my dE is k times lambda times dx over x squared plus y squared. This thing's going to create electric field. Where is the electric field going to go? If I was to come up here to this blue dot and draw the electric field in green, where is it going to go? There's a positive line charge based on a little point that's right there at the origin. Where is this electric field going to go? We're going to go towards it or away from it? I'm going to go away from it. Why am I going away from it? Because it's positive. If it was negative, where would I go? I would go towards it. So I'm going off at this angle. I have something happening at an angle. If I want to find what the field is, what do I have to do to the angle? What do we do with forces every time? Split it into x and y. So I have to do that. So I have a little bit going in the x and a little bit going in the y direction. So I can figure out what the ex is, and I can figure out what ey is. But to do that, I have to take this general differential equation, dE, and I have to put it into the x piece and the y piece. So I have to find dE in the x direction. That's going to be dE, which is k times lambda times dx over x squared plus y squared. And how do I get out just the x part of that? Look at my triangle. What part of that triangle gives me just the x part? A blue triangle. There's my angle. What's the x part? Opposite side is the x. So that's the sine. So I multiply this by sine of theta. That gives me the x piece. If I want the y piece, dEy, I do cosine. K times lambda times dx over x squared plus y squared times cosine of theta. Even though it's the y piece, this dx still stays. Because that's where the charge is spread out along dx. I don't need to change anything for the y direction. Okay. Sine of theta, cosine theta, I figured out what those both were. It's earlier in the video, it's way up here. I can plug those values in. So anywhere I see sine of theta, I can plug in the x divided by square root of x squared plus y squared. So I do that. So dEx is now k times lambda times dx over x squared plus y squared times x over square root of x squared plus y squared. And dEy is k times lambda times dx over x squared plus y squared times, oh gosh, that was y divided by square root of x squared plus y squared. This looks horrible. It hasn't been that horrible, though. I've just been plugging in things. Okay. Now from here, it looks like it's going to be awful. How do I get rid of dEx? How do I get rid of the d? Integrate. So I integrate both sides. Take the integral of both of these. So then I get out ex. Anything that is not an x or associated with an x, I can take outside of the integral. What can I take outside of the first integral? K and lambda come out. So this is x times dx over x squared plus y squared to the 3/2. So there's my x. Comes right down. X squared plus y squared times x squared plus y squared square root. x squared plus y squared to the 3 halves. Thank you. Maybe you'll be lucky and I caught pneumonia riding my bike in the wind and rain, and we won't have class on Thursday.
That's so funny. What a great joke.
We could. We could. You're biology majors. You got one of you who keeps printing viruses in the lab trying to infect me. That's how biology works, right? So I need to do the second side. DEY. Integrate DEY, get EY. What can I pull out of that integral? I can pull out K, lambda, and Y. And I'm left with dx over x squared plus y squared to the 3 halves. Now here's where the magic happens. K times lambda times -1 over the square root of x squared plus y squared. These are all between 0 and infinity. How do I go from here to here? Yeah, that's a good question. How did I do that? This is a general integral. This is from a table. U substitution will let you do that. If you needed that on the exam, I'll give it to you. You don't have to do U substitution or UV substitution or any of that stuff. Okay, I will give you the general integral. Same thing here with the EY. EY, that is a general integral that nerds before us have solved.
I have a so would this table be given to us, or is one of the tables you gave us?
I would give it to you. 4 pi epsilon naught x over y squared times the square root of x squared plus y squared. Going from here to here is some black magic. Witchcraft, wizardry. People have calculated it for us, so we don't.
Is there a reason you put the 4 pi epsilon naught sub k on that one? Or
That's what I did in my solutions, so I just copied it down.
Yeah, that
just make
makes sense.
Where did that y squared come from? If you want to see it, come to my office and we'll do it with UV substitution. It's a process to solve this interval. This is not an easy interval.
But you'll give it to us.
Yeah, I will give you this, so I won't give you that, but I'll give you this integral is equal to this. It evaluates two. Yeah, I'll give you both of those general integrals if you need them. I might even give them to you even if you don't need them. Just to throw you off the track.
Wait, sorry, one more time? What?
I guarantee. Actually, I think I did put those integrals on there. I don't remember if you need them or not, but I think I put them on there just in case. And people will just use them just because they think that they need them, and then will have no use at all. That'd be. Maybe I'll do that. Maybe I'll change the exam so I do that.
Wait, for us? For like your next class? When you
No, I
come
think
back
for
from
you. Yeah,
sabbatical.
Nathaniel.
Do you like watching people cry?
Do I like watching them cry?
Yeah.
No.
Okay, then why are you doing it?
Why am I doing what?
All of this, everything.
Because it's physics. Sorry. I did get rid of a problem. Okay, let's do another one. Unless there are any other questions on that one. Nothing else on that one? Huh?
Is that the hardest that you're gonna get?
That's probably one. That's one of the harder ones.
But it's like not gonna get harder.
No, I don't think so.
Like meaning that there's not gonna be like so much curveball that's throwing it down.
No. I don't think I throw you curveballs on exams.
But when you do like with this, when you like put multiple concepts in one, it like throws curveballs.
Sure.
Like, if this is the hardest ever get for this kind of concept.
So to give you an idea, something like this, I would not add extra things to this. extra parts, extra portions, because this is hard enough. Something like the next problem. The next problem is actually easy enough that I might add extra pieces to it.
That's fine. That was my question was. That you think is the electric field.
That's for the electric field.
So we just want to find that equation.
Yeah. Electric field.
All right.
Fine.
I'm just clarifying.
Yeah. Yeah. All right. No other questions on this one?
Is that the final answer?
Yeah. Just those two equations. Let's do number 77. 77, we have 3-point charges, negative q, positive 2q, and negative q that are arranged on a straight line as illustrated in a figure. What is the electric field that these charges produce at a distance y above the central charge? So this is chapter 23, number 77. Yes. We've got a negative charge q, a negative charge q, and then at the very middle we have a positive charge 2q. And then we want to know what is the electric field some distance above this. And they give us a distance y. And a distance d. I want to know the electric field up there, a distance y above the middle charge, and a distance d to the left of the negative charges. So the first thing I would do is I would draw what electric fields these things create. So the electric field due to this negative charge, this one on the left. What direction is the electric field on this point going to go because of this charge? This point, due to this charge. Where am I going to go? This point here, due to this charge. Where do I go? Towards it or away from it? Towards it, yeah. So we'll call that E1. How about this charge right here, due to this positive 2q? Where's it going to go? This charge, due to the positive 2q. Do I go towards it or away from it? Away. Why? Because it's positive, so I'm going to be pointing away. So we'll call that E2. And then the last two pair of charges. Charge that I put right here. Where's it going to go due to that negative? Towards it. E3. I have charges that are going at angles. If I have things going at angles, what do? Draw x and y directions. So I do it for the left, I do it for the right. Okay. So I've drawn my little vectors in that represent that. What can I notice about E1x and E3x? Same distance, but what direction? Opposite. If they're the same magnitude but opposite directions, what do? Cancel out. So how much how much electric field do I have in the x direction? None. Goes away. So I only have to calculate the electric field in the y direction. So EY, the total electric field is going to be E2 minus E1 in the y minus E2 in the y. Oh, my iPad ran out of room. It has long bezels. So I can't tell. So we have E2 going up. So it's positive. Yeah? E1y is negative. Why is it negative? Because it's going down. E2y. Why is it negative? Going down. What do I know about E1y and E2y? Same size. E1y and E3y. That's the 3. I can't read my own handwriting. This is why doctors shouldn't teach classes. I used to have great handwriting, But as soon as you get a PhD, your handwriting becomes shit. It's automatic.
So I heard.
Requirement. Yeah. Any of you know Philip? Philip Bowie? He will never be a doctor. His handwriting is way too pretty.
Philip.
Yeah. EY equals E2 minus E1Y minus E3Y. Okay. So I need to figure out what all these are. I have multiple equations that I can use for figuring out E. Do I need to use the E equation? E equals KQ over R squared, or DE equals K DQ over R squared? Which one? Do I have distinct charges or do I have charges spread out?
Spread out.
I have distinct charges. They are in different places, but they're not spread along a surface. They're not along a line, they're not along a surface, they're not along a volume. So do I use the easy equation or the hard equation? Easy. Easy equation, yay. Woo! So am I going to give you this on the exam? No. Heck no, that's way too easy. I don't remember if I gave this to you or not. I don't. E1 equals K. Let's do E2 first. E2 is the easiest. E2 goes straight up, right? So that's going to be K times the charge that creates the electric field. How big is the charge that's creating that blue line? 2Q. So that's K times 2Q. Divided by R squared. That's the distance. How far is it from 2Q up to the point of interest? Y. So this is K times 2Q over Y squared. Yeah? Okay. How about E1Y? What's E1Y? Negative K. Why negative? Because it's going down. What's the charge? Q. Positive or negative? The charge is negative, which determines the direction, but when you plug it into the equation, you use positive Q. That negative, where did it come from? The fact that it's going down. Okay. Now we need to divide by the separation. So how far is it from that position, that little red charge, up to the point? So this was D, this was Y, R equals square root of Y squared plus D squared. Square root of Y squared plus D squared squared is Y squared plus D squared. That is the total electric field. Do I want the total electric field? No, I want just the Y direction. How do I get just the Y direction out of that? I have to pick an angle, don't I? C. Let's make the picture even messier. There's my triangle. I know this is Y, this is D, this is the hypotenuse. Hypotenuse was, what is that? R. What angle do you want? Bottom corner or top corner?
Oh, no, you want top.
Doesn't matter, whichever one you want. You want the bottom one?
Yes.
Okay. Bottom one. So that's my theta. So if I want to pull out just the Y portion, what do I multiply this by? Sine theta or cosine theta, if that's my theta? What part of this yellow triangle is the Y side? Opposite side. So is that sine or cosine? Sine. So if I multiply this by the sine, I just got out the Y portion. But the sine of this angle, I can write it in terms of the variables that I was given. So I need to do that. What is sine of theta in terms of the variables I was given? Y over R. So E1Y is equal to negative k times q over y squared plus d squared times, we did y over square root of y squared plus d squared. Any questions on that? So now we can do the total force, the total field is equal to k times 2q over y squared minus 2 times k times q over y squared plus d squared times y over square root of y squared plus d squared. Is that really the answer? Not a number? Yeah, that's right.
Yeah. Typically, it's like all the same steps. As someone before it, you just don't follow the
You don't do derivatives and integrals. Same exact thing. Same approach. Same stuff. Same stuff that you were doing in physics 1. Gravity, figuring out forces, all over the place. Okay? Same procedure, same math, just slightly different applications. Any other questions on this one? What if we used a different angle? What if I would have used the top angle? Would I get the same answer? Andrew, do me a favor. Look at that. Is that the same answer? I forgot the K there.
It's not the same.
What if I put a K there?
Okay, then yeah. Our technicality.
Yeah? Yeah? So it's the same answer. But what angle did I pick? Let's look. Catherine said that's the same. What angle did I pick?
You pick the top.
I picked the top angle, so you got the same answer. Doesn't matter. Okay? No preguntas? No questions on that one? No? That's the end?
Gracias.
Okay. Those are all the questions that I had time to come up with good answers to.